Hi friends, good evening, welcome to GATE Academy. Am I audible, visible? Anyone is there or not? No one is there. Wow, day by day no one is coming here. I thought people will increase. Hi friends, good evening, good evening, good evening guys. Anyone please? Is there anyone in the class? No one? You got bored of me? Am I not that entertaining? Good evening guys. Hey, hi Shihana, good evening. Pradeep, good evening. Two people came, 7 people are watching. One is me, another is Pradeep, another one is Shihana. Who are the other guys? Please do comment. Please keep it up for the sake of God. What I have to keep it up, Suhai? I don't know what I have to keep it up. Good evening, good evening. Who is that guy? Good evening. Kuldeep Kumar, good evening. Am I audible guys? Am I audible? And visibility, is it good? Please do comment, audible and visible, whether I am audible or not. Please do comment. All perfect? Yeah. Visibility not. What happened to visibility? Anything wrong? I think I am visible here. I can see myself over there. What is the problem with the visibility? Light? I think many people were not there in the morning's class. Sorry for the disturbance. Visible? Written on board is not visible. Fine, I'll discuss about that. Okay, so till now we have seen how to find out shape factor, how to find out plastic moment capacity, and how to find out elastic modulus, how to find out plastic modulus. In the morning I took half an hour of class because many people were not there, and please as I have already discussed, morning 2 hours, evening 2 hours will be your timetable, 7 to 9. Please to like, share with as many people as possible, because hardly I have seen any people in the morning. I don't know why. So yeah, yep. Now we'll go for the next type of questions that can be asked. Fine. So idea is to find out the collapse load. Idea is to find out the collapse load. There are different ways to find out the collapse load, but the major things if we have to discuss, major things, if you want to find out the collapse load, always use principle of virtual work done. Principle of virtual work. Okay, we'll be using principle of virtual work to find out the collapse load. Okay, This is used to find out the collapse load. To find out collapse load. Fine. Before that, we'll see what exactly is mechanism. Fine. Mechanism. Whenever you take a structure, whenever you take any structure, fine, you're taking a structure over here. Let us say this is a simply supported beam. Simply supported beam subjected to some loading P. Simply supported beam subjected to some loading P. What is the static indeterminacy of this structure? ds would be equals to number of reactions minus number of equilibrium equations. If it is subjected to vertical load, then there are only two equilibrium equations, right? So equilibrium equations would be sigma Fy equals to 0, summation of moment equals to 0. Generally, sigma Fx is also equals to 0, that is also an equilibrium equation. But if it is subjected to only vertical load, there are only two equilibrium equations. And number of reactions here, this is 1, this is also 1. You will be considering only 1 reactions. R equals to 2, S equals to 2. ds equals to 2 minus 2, that equals to 0. So ds equals to 0. This is statically determinate and stable. So if it is statically determinate and stable, in order to convert this into mechanism, in order to make it unstable, then how many hinges is to be formed? Number of hinges required, number of hinges required, number of hinges required to convert a structure into mechanism. That means we are going to convert a stable structure into unstable structure. Number of hinges required, n would be equals to ds plus 1, that is 0 plus 1. 1 hinge. 1 hinge is required to convert whole structure into a mechanism. That means if you take this, if you take this as a structure, so now it is stable structure. If you keep on increasing the load, what happens? Initially it will bend, right? So it will bend like this, it will keep on bending like this, and there comes a stage where it will totally collapse. Beam will totally collapse like this. Beam would be totally collapsing like this. Fine. So this is how it would be collapsed. Beam will be collapsed. That means indirectly a hinge is formed here. The load at which beam collapses is called as collapse load. Collapse load is the load at which beam collapses. You'll keep on increasing the load and finally it collapses. It bends. If it reaches up to the plastic moment capacity, it collapses. Fine. It collapses. Okay. So this is what you'll be saying. Number of hinges required to convert a structure into mechanism. Mechanism means we are making the structure unstable. Fine. So here the number of hinges required to convert a structure into mechanism is generally ds plus 1, where ds is the static indeterminacy. So here the number of hinges required is 1. And possibility of formation, location of hinges. Where does hinges will form? So generally hinges will form, possibility of location of hinges, possibility of location of hinges. So the first one is place where bending moment is maximum. Location of maximum bending moment. It can be formed at location of maximum bending moment. Fine. at fixed supports, at fixed supports, at fixed supports, under point load, under point loads. It can form under point loads. Next, location where cross section changes, location where cross section changes, and location where material changes, location where material, location where cross section changes, and location where material changes. So these are the point: location of maximum bending moment at fixed supports, under point loads, location where cross section changes, and location where material changes. So these are the possible location of hinges. Where does the hinges will form? So these are the possible location of hinges. If bending moment is maximum, generally if you see here, bending moment is maximum here only, and point load is also here, so possibility of location of hinge would be here. If a third hinge is formed, this is totally become, this structure becomes unstable. That means structure is converted into mechanism. Fine. Here the structure is converted into mechanism. Fine. Suppose if you are taking any example of fixed beam, if I am taking example of fixed beam, this is a fixed beam subjected to a point load, something like this, subjected to a vertical load P, subjected to a vertical load P. One reaction will be like this, another reaction will be like this, and moments, consider the moments would be something like this, moments would be something like this. ds would be equals to r minus s. Number of reactions equals to 4, number of equilibrium equations we have already discussed, it equals to 3. So ds would be equals to, or number of hinges required to be formed to convert structure into mechanism is ds plus 1, that is 2 plus 1, that equals to 3. 3 hinges has to be formed. What are the possible locations? I told you, first one, it can form at fixed supports. So here 2 hinges will form, and another hinge might be forming under the load or under the location of maximum bending moment, under the location of maximum bending moment. That means if structure fails, it will fail something like this. 3 hinges will be formed so that the structure is converted into mechanism. Fine. Structure is converted into mechanism. Fine. Now the next one is how to find out collapse load. I told you we will be using principle of virtual work done to find out the collapse loads. Collapse load means the load at which material fails or structure is converted into mechanism. So you can use equilibrium concept, mechanism concept, and the other concepts, but first I will discuss by using principle of virtual work done how you are going to find out the collapse loads. Fine. So principle of virtual work done. What does principle of virtual work done says? Virtual work done. Principle of virtual work done. If a structure is in equilibrium, if a structure is in equilibrium, then total work done by all the forces is 0. That means work done by external force plus work done by internal reactions, work done by external forces plus work done by internal reactions equals to 0. Fine. work done by external forces plus work done by internal reactions equals to 0. This is the principle of virtual work. Now how you will be using this principle of virtual work is, I'll take a simply supported beam subjected to point load at center. Simply supported beam subjected to point load at center. I am just considering a simply supported beam subjected to point load at the center. Now what I can say is, if I take this as a simply supported beam of length L, if this is L and load that is acting is P, subjected to point load P at the center, this is P, this is L by 2, this is also L by 2. Number of hinges required to convert the structure into mechanism would be N equals to ds plus 1, and this is statically determinate structure. Just now we have seen 0 plus 1, that equals to 1. Number of hinges required to be formed is 1. Okay, so number of hinges required to be formed is 1. Fine, number of hinges required to be formed is 1. Then what you can say over here is, hinge will be formed, let us say at C. If I take this as A, C, B, hinge will form at C. Just before collapse, it would be something like this. It will try to rotate something like this just before collapse. Fine, a hinge is formed over here. That means the moment resisting capacity would be MP. This is MP, this is also MP, and let us say this is L by 2, this is L by 2, this is theta, this is also theta. This is theta, this is theta. Fine. So what is external work done? Load multiplied with distance in the direction of the applied load. If this is L by 2, this is theta, I can write this as L by 2 times theta. If this is theta, this is L by 2. If I take this as y, tan theta equals to y upon L by 2. For small values of theta, tan theta is approximately equal to theta. Theta equals to y upon L by 2. This implies y equals to L theta by 2. So this is L theta upon 2. Fine, this distance is L by 2 times theta or L theta upon 2. So external work done by external forces is Pu into L by 2 times theta, right? Work done by external force, work done by external force equals to Pu or P multiplied with L by 2 times theta. Okay, and what is work done by internal force? Work done by internal force is MP is anti-clockwise and theta is clockwise, so it is opposite. MP into theta, both are opposite, so minus MP into theta and MP into theta. See, if load is trying to push it like this, the internal rotation, that means capacity, will try to resist this. If this tries to rotate like this, this tries to resist. That is the reason here it is clockwise moment, here it is anti-clockwise moment, whereas rotation is clockwise here, rotation is anti-clockwise here. So internal minus MP into theta minus MP into theta, because moment and theta in opposite direction. So as per principle of virtual work, what I can write is P multiplied with L by 2 times theta equals to 2 mp theta. So P equals to 4 mp upon L. Collapse load is 4 mp upon L, whereas mp equals to plastic moment capacity. mp equals to plastic moment capacity. P equals to 4 mp upon L. This is the collapse load, plastic moment capacity. This is constant for a given section, right? It depends upon Fy multiplied with Zp, constant for a given cross sectional area. Fine. So this is how we are going to find out plastic moment capacity, mp. Not plastic moment capacity, collapse load. So whenever any problem is given to you, try to use principle of virtual work done. Fine. So work done by external forces equals to work done by internal forces. What is work done by external forces? For that, first you should find out number of hinges that is to be formed to convert a structure into mechanism. Once this is converted, so work done by external forces P into L by 2 times theta. Work done by internal force or reactions is minus mp into theta minus mp into theta. This is internal reactions. So as per the principle of virtual work done, the collapse load is given as 4 mp upon L. This is for simply supported beam subjected to point load at the center. Any doubts in this? You can ask me. Good evening. Only 4 people are watching, so you are getting bored. Work done by internal reactions again. See Prithvi, if a load is being applied like this, load tries to rotate this. Fine. Internal reaction, that means there is some moment. When you try to rotate, the moment over there, that means if you see, if a load is being applied, I am trying to rotate like this. If there is any fixity over here, I'll resist it. That means if you try to rotate it like this, I'll resist it. So here a moment is developed, right? So here a moment is developed. That is plastic moment capacity, your capacity. The capacity of beam is generated here, mp, right? So mp multiplied with theta, this is clockwise moment and there is anti-clockwise rotation. So mp multiplied with theta, mp anti-clockwise multiplied with clockwise rotation theta. So work done by internal reactions is minus y, because mp and theta are in opposite direction. Generally work done by any force is load multiplied with distance traveled. So mp multiplied with theta, mp multiplied with theta. Here because there are 2 reactions that is developed, so 2 mp into theta. Any doubts? Only 4 people are watching. Yeah, thank you very much. Any doubts, guys? Got it? No doubts? Fine. In the same line, if you want to find out for a simply supported beam subjected to UDL, simply supported beam subjected to UDL. If you are taking a simply supported beam subjected to UDL, W kilonewton per meter, let us say. Fine. So if it is W kilonewton per meter, then number of hinges required to convert this into mechanism, that is ds plus 1. ds anyway equals to 0, n equals to 0 plus 1, so n equals to 1. Number of hinges required to be formed is 1. So generally moment will be more at the center. What is that? WL square upon 8. So hinges will be forming at the center only. So this would be exactly at the center. This will form exactly at the center. Fine. So this whole thing is if this is L, this is L by 2, this is also L by 2, this is theta, this is also theta rotation. But here the only thing is the load is W kilonewton per meter. So if you want to find out work done by external force, that is load multiplied with this whole area you have to take. This whole area, that means this is L by 2 times theta. So external work done would be equals to external work done equals to load multiplied with area. Area under the load is half L multiplied with L by 2 times theta. This area you will be taking. Half multiplied with L multiplied with L by 2 theta. And internal work done would be MP. Fine. So this would be theta. This is also theta. So internal work done equals to MP times theta plus MP times theta. Fine. So WL square by 4 equals to 2 MP theta. So W would be equals to 8 MP upon L square. W is 8 MP upon L square. Therefore the collapse load for a simply supported beam subjected to UDL, collapse load is 8 MP upon L square. 8 MP upon L square. Fine. Any doubts in this? You can ask me. Only 5 people are watching. Please do like, share, subscribe with as many people as possible. And if there is anything that you want me to say, please let me know. I'll discuss that. And I don't know why many people are not present. Am I going fast or you are getting bored? Any valuable suggestions is okay with me. So any doubts over here? Any doubts in this? Prithviraj is saying no doubt. Hey Suhani, rather your videos are much more helpful for us. Please make more videos on this subject and complete our ERC syllabus, please. Humble request. Written on board is not visible, sir. Not clearly visible, blurred. Why it is blurred here? Lighting effect is high. Anyway guys, any doubts in this? This is your case 2, simply supported beam subjected to UDL. Case 2. Case 1, simply supported beam subjected to point load. Simply supported beam with UDL. Next, this is your case 2. Case 3. Case 3 is simply supported beam. Case 3, simply supported beam with point load anywhere, with point load anywhere, with point load anywhere. Okay, simply supported beam with point load anywhere. How exactly you are going to find that out? If let us say point load is somewhere here, this is A, this is B, W, capital W. Number of hinges required to convert this into mechanism, n equals to ds plus 1, ds equals to 0 plus 1, that equals to 1. N equals to 1, not a bigger issue. Fine. So if n equals to 1, which will be formed under the load. Always remember the third hinge here, maximum bending moment, that will be under the load only. So it will be forming under the load. The third hinge will form under the load. Fine. So if hinges form something like this, this is A, this is B. Now the angles will not be same. This will be alpha, this will be beta. So this is A alpha, this can also be B beta. And moment, plastic moment capacity MP, MP will be like this. Fine. So this is theta, this is also theta. Fine. Both are theta, theta, not theta, sorry, alpha, beta. If this is alpha, this is also alpha, this is beta, this is also beta. So what is external work done? External work done would be equals to load multiplied with distance travel, that is A alpha. A alpha. Internal work done would be equals to MP times alpha plus MP times beta. So W multiplied with A alpha equals to MP times alpha plus beta. And what you can write is A alpha equals to B beta. A alpha equals to B beta. So beta would be equals to A alpha by B. W into A alpha equals to MP multiplied with alpha plus A alpha by B. W would be equals to MP multiplied with B plus A upon AB. B plus A is L. MP L upon A B. MP L upon A B. Fine. This is how you will calculate W. Load, collapse load. This is the collapse load for a simply supported beam with point load anywhere. Collapse load. Any doubts in this? You can ask me. Any doubts? Please go ahead and ask me. Any doubts, guys? Only 6 people are watching. I don't know why you got bored of it. So please do comment. Neetu Anu. Good evening. Prudviraj. Only Prudviraj is being constantly messaging me. What about the other guys? Please do comment, guys. Clear? This is how you are going to find out collapse load when a simply supported beam is subjected to point load anywhere. See, you can take notes and everything. If possible, take the notes. If not, first try to understand the concept. This is revision. That means you have already studied this. That's why I'm going at faster rate. So try to understand the concept. Once you understand the concept, that is enough. Notes you can write afterwards also, because if you like the video would be with you only. Fine. But first try to understand the concepts. So in simply supported beam with point load at the center, collapse load is 4 MPa upon L. With uniformly distributed load 8 MPa upon L square. With point load anywhere MP L upon A into B. Fine. Simply supported beam is completed. Next we go for fixed beam. So fixed beam, case 1, fixed beam, point load fixed beam with point load at center. Fixed beam with point load. Fixed beam with point load at center. Right? So fixed beam with point load at center. P will be acting something over here. So here this is load P. Now this is a fixed beam. So what is static indeterminacy for fixed beam? Subjected to vertical loads only. Here there will be one reaction, here there will be one reaction, here there will be one reaction. Number of reactions is 4, number of equilibrium equations equals to 2, ds is 4 minus 2, that is 2. Number of hinges required to be formed is ds plus 1, that is 2 plus 1, 3. 2 plus 1, 3. 3 hinges is to be formed. And where does these 3 hinges will be formed? If you remember, I told you hinges will be formed at fixed supports under the load and at maximum bending moment and under the load and all those things, right? And if there is any change in cross section, any change in the material, all those points you have to check. Fine. Now if this is load P exactly at center, L by 2, L by 2, so it will form at A, B, C. Plastic hinges will form at A, B and C. That means final the collapse load diagram would be something like this. Something like this. So here there is a plastic moment capacity of MP. Here there is a plastic moment capacity of another MP. Here there is plastic moment capacity of MP that will be generated. Here there is plastic moment capacity of MP. If this is theta, this is also theta, then this would be L by 2 times theta. Why? A hinge is developed here, a hinge is developed here, so a plastic moment capacitors will be developed here, right? That means this load tries to rotate it like this. Here the fixed support tries to resist it. If it is hinge means easy to rotate. That's why moments are now developed over here, whereas here moments are developed at different locations. Fine. I'll say this as theta, this also as theta. Fine. So what would be the external work done? External work done equals to P multiplied with L by 2 times theta. P multiplied with L by 2 times theta. Internal work done equals to MP times theta. Here it is MP times theta, here MP times theta plus MP times theta, and here it is MP times theta, right? This is at A, and this is MP times theta plus MP times theta. This is at B plus MP times theta. This is at C, and this is at B. So totally what you can write is P multiplied with L by 2 times theta equals to 1, 2, 3, 4. That equals to 4 MP into theta. So P would be equals to 8 MP upon L. So collapse load for a fixed beam subjected to point load at center is 8 MP by L. If it is a simply supported beam, then it is 4 MP upon L. If it is a fixed beam, then it is 8 MP upon L. So collapse load for a fixed beam subjected to point load at center is 8 MP upon L. Fine. So this is how you will calculate. And how the hinges are formed, that means in what way hinges are formed, that depends actually on bending moment diagram. That means if you are taking if it is a fixed beam subjected to point load at center, from your strength of materials concept, the moments developed at the ends, fixed end moments would be WL upon 8 and WL upon 8. This is fixed end moments, P or W, whatever that is. This is WL upon 8, L by 2. The fixed end moments that is developed is WL by 8. If there is no fixed supports, if there is only hinge support, then bending moment diagram would be how much? WL by 4. At the center it is WL by 4, right? This is BMD. Now the moments developed because of load applied, the moments developed at the ends is WL by 8. If this is positive bending moment, this is negative. Because of this it bends like this, sagging, and because of moments it is hogging, negative. Fine. So this is negative. This is also negative, WL upon 8. This is also WL upon 8. WL by 4 and this is WL upon 8. The positive bending moment, what would be this value? WL by 4 minus WL upon 8. This would be WL upon 8. This is maximum positive bending moment and this is maximum negative bending moment. This is from your bending moment diagram concept, which you might have studied in your structure analysis. This is BMD. This triangle is a BMD with point load at the center for an SSB, simply supported beam. If you are providing the fixity at the ends, then you will be adding these moments, minus WL by 8. So since maximum negative bending moment at A and B, maximum negative bending moment is WL by 8. At C, the maximum positive bending moment is WL by 8. At all the 3 points, hinges will be formed together. That means bending moments is same, maximum bending moments is same at 3 locations. So 3 hinges will be formed together. Fine. So here all three hinges will form together at A, B and C, since maximum negative bending moment equals to maximum positive bending moment equals to WL upon 8. So since bending moments are same, fine, all the 3 hinges, when you keep on increasing the load at the failure, all hinges will be formed and failure occurs. And what is the collapse load? Collapse load is 8 MP upon L. Fine. Any doubts in this? You can ask me. Namaskaram, only path. You are late to the class. Any doubts in this, guys? Only 6 people are watching. Please do like, share, subscribe with as many people as possible. Very less crowd. I don't know why. Anyway, any doubts, guys? See, the concept is very much simple. Whenever, just find out number of hinges required to be formed, location of hinges. So here these are the three locations of hinges, and finally you can find out what is the collapse load that is required to be formed. So, and hinges will be formed simultaneously at A, B and C. Any doubts, guys? Only Prithviraj is commenting. What about the other guys? If you are having any doubts, please go ahead and ask now only, because this is the time where you can clear the doubts. If you don't clear doubts now also, then it would be difficult. If you want me to repeat, I'll repeat. Since it is starting, I know it is difficult to take, be with the pace. So if you are having any doubts, please go ahead and ask. Any doubts, guys? Fine. Next concept would be fixed beam supported to UDL. Fixed beam supported to UDL, right? W kilonewton per meter of length L. Fixed beam supported to UDL of W kilonewton per meter, length L. Okay. Then what is ds? ds will not change. That is static indeterminacy. ds equals to 2. Number of hinges required to be formed is 2 plus 1, that equals to 3. So it will form at A, B and C. C would be exactly at the center, because maximum bending moment will be at the center. So it will be something like this. This is theta, this is also theta, and the length is L by 2 times theta. L by 2 times theta. This is L by 2, this is also L by 2. Fine. Here the moment developed is MP. Here the moment developed is will be MP. Fine. And here the moment developed is MP. Here the moment developed is MP. And this is theta. This will also be theta. Fine. So what I can write down is, what is the external work done when UDL is applied, load multiplied with area, right? So external work done equals to load multiplied with area, half multiplied with L by 2 times theta. And what is internal work done? Internal work done equals to MP into theta, MP into theta, MP into theta, MP into theta, right? So MP multiplied with theta plus MP multiplied with theta plus MP multiplied with theta plus MP multiplied with theta. This is at B, sorry, this is at C, that means exactly at the center, and this is at B. So value would be WL square by 4 times theta, that equals to 4 MP theta. So W would be equals to 16 MP upon L square. 16 MPa upon L square. This is collapse load. Collapse load for a fixed beam subjected to UDL, collapse load is 16 MPa upon L square. Fine. Any doubts? Only 6 people are watching. Today, not even 10 people were present. What happened? What happened? I think people got bored, or is there any issues? Any doubts, guys? Please do comment. 8 people are watching. Please do comment. If you comment, then only I can understand whether you understood the concepts or not. If not, how come I'll know that you understood the concept or not? Or it's like, in the early morning class, what happened is I took class at 7 a.m. and there were hardly 2 people or 1 people, and I have stopped taking classes after half an hour, because I don't know whom I am teaching, whom I am saying the things. I asked you the timing, whether 7 to 9 is okay with you or not. So if timings is, if you want me to change the timings, I'll change the timings. If you want me to change the subject, I'll change the subject. So please be clear, what do you want? Fine, and come. This is, I think this is one of the opportunity for revision. Okay, so I don't want to revise for myself. I want you people to revise. I want to help you out to revise. That means what to study, what not to study, and what are the major topics. I am discussing only the major topics here, so that previous years, if you are able to solve previous years GATE questions properly, then automatically you will score 60 plus marks here. Believe me, if you solve previous year's questions of all the subjects, you will score 60 plus marks. And if you are clear with all the concepts, then you will score 80 plus marks. And if you know how to apply, then you will get 90 plus marks. As simple logic as that. Fine. So please do comment. Please do keep on commenting. If you want me to repeat, I'll repeat, because this is the time where you can ask me. I can take another 5 minutes of time and repeat. But if you don't ask me, I can't repeat, and you won't be getting any thoughts in this. Fine. So that is the collapse load, 16 MPa upon L square. Any doubts, you can ask me. So Binga said no doubts. Continue with steel, sir. Fine. The only path is laughing. I don't know why people are laughing. It's nice to have a laugh. At the same time, it's better to read. Now, collapse. Now 3 hinges are formed. When it is subjected to UDL, 3 hinges are formed, right? If now at what is the how hinges are formed? That means, as I said, all the hinges are formed simultaneously in this time period, whereas how the hinges are formed over here, whether it would be simultaneous or whether it would be in a different fashion. So for that, you should draw a bending moment diagram. You should draw a bending moment diagram. Generally, for a simply supported beam subjected to UDL, W L square upon if subjected to UDL of W kilonewton per meter, then generally the bending moment diagram would be something like this. W L square upon 8. Fine. This is W L square upon 8 subjected to UDL. Next, what are the moments developed here? WL square by 24, WL square by 12, fixed end moments. This is fixed end moments, WL square upon 12. If this is your fixed end moments, then bending moment would be something like this. This is negative, this would be positive, this is negative. This is final bending moment diagram, WL square by 12. Here it is WL square upon 12. And here, then what would be this value? See, this whole value is WL square upon 8. This is WL square upon 12. This would be WL square by 8 minus WL square by 12. That is WL square by 24. Fine. Only this value is WL square by 24. Maximum negative bending moment is WL square by 12, and maximum positive bending moment is WL square by 24. Since bending moment is more, first hinges are formed at A and B. That means at fixed supports. First hinges are formed at A and B. Next, if you further increase the load, then hinge will form at C, because bending moment at C is less compared to that of A and B. Fine. So the note would be since negative bending moment is high at A and B, first hinges are formed at A and B simultaneously, followed by hinge at C. That is positive bending moment maximum positive bending moment. Fine. Okay, so at C, so at 16 MP by L square, hinges are formed simultaneously. First hinges are formed at A and B, because negative bending moment is maximum, WL square by 12. WL square by 12, that equals to MP if I have to take. Since hinges are formed at a moment of WL square by 12, the load at which hinges are formed at A and B. The load at which hinges are formed at A and B equals to, how you are going to find out is MP equals to WL square by 12. W would be equals to 12 MP upon L square. Fine. At a load of 12 MP by L square, if you keep on increasing the load up to 12 MP by L square, hinges are formed at A and B. Now, if you increase this to 16 MP by L square, then hinges are formed at A, B and C, and there is a hinge will form at A, B and C. You can see that collapse load is 16 MP by L square. If you increase this up to 16 MP by, if it is up to 12 MP by L square, hinges are formed at A and B. If you increase this to 16 MP by L square, hinges are formed at A, B and C. That means next hinge will be formed at C. Fine. Any doubts in this? You can ask me. Any doubts? Only 4 people are watching. So everyone, I don't know where people went. Only 4 people are watching. 5 people. I think you people are getting bored. I have to do something. Yeah, let me think about it. Nothing is coming in my mind. Any doubts in this, guys? One person, Prithvi Raj, no doubt. Thank you, Prithvi. At least you are commenting. Other guys, there are no other guys. Only one, me, Prithvi, 2, That's it. And I don't know who are those 3 or 2 guys. Rest of the people left. This is 12 MP by L square. I mean, this is how hinges are formed. Next is fixed beam with point load anywhere. Fixed beam with point load anywhere. Fixed beam with point load anywhere. Number of hinges that is to be required to be formed is ds would be equals to 2. Number of hinges required to be formed is 3. That will not change. Fine. And if I take this as A, this is B, this is W, A, B, alpha, beta, A alpha, B beta, and this is MP. This one is also MP, this one is also MP, and this is also MP. This is beta, this one is alpha. Fine. Anyway, third hinge will be forming under the load only. Okay. Now external work done, if they ask, external work done equals to W multiplied with A alpha, internal work done equals to MP multiplied with alpha plus MP multiplied with alpha plus beta plus MP multiplied with beta. So this is equals to 2MP alpha plus beta, and we know A alpha equals to B beta. Beta would be equals to A alpha upon B. So W times A alpha equals to 2MP times alpha plus A alpha by B. So that equals to 2MP times B plus A upon B alpha. W multiplied with A alpha. So W would be equals to 2MP L upon AB. W equals to 2MPL upon AB. This is the collapse load. Simple. Collapse load. Fine. If it is the collapse load, then how it will be formed? Generally, because of the loading, here it would be, moment would be less, W B square A upon L square, and here moment will be more, W A square B upon L square. So first plastic hinge will be forming at B. Next it can be at A and C, depending upon the values of moments at A and C. Fine. So first plastic hinge is formed at B. Why, sir? Why at B? Because A value is more than B, W A square B upon L square. Moment is high. If load is near to A, then moment will be high at A. So accordingly you have to judge. Here first plastic moment is formed at, hinge is formed at B, because moment is high at B. Because moment is high at B, followed by anywhere at A and C, depending upon values of moments at A and C. Depending upon values of moments at A and C. If moment at A is more, it is formed at A. If moment at C is more, it is formed at C. Any doubts in this? You can ask me. Any doubts? 7 people are watching. Seven people are watching. Any doubts? Any doubts? Please do comment, guys. The only path commented. What about the other paths? Hey, there is a big message. What is that big message, Ray? Shyama Raman Patnaik. Good evening, sir. Collapse load due to static method and due to dynamic method is what, sir? Oh, nice. I'll discuss that. Static method and dynamic method. It's like, kinetic method and static method. It's simple. It's accordingly. I'll discuss that anyway. Nice point is raised. I'll discuss that. Any doubts up to here? I'll discuss that, Patnaik. Don't worry. Any doubts up to here? Two people commented clear sir, clear sir. What about the other people? Not clear? If it is not clear to you, you can tell me, no issues. Fine. And I told you, if there is any cross-sectional changes, or material changes, if cross-section changes or material changes, the plastic hinge can also form over there. That means if load is being applied over here, number of plastic hinges required to be formed is 3, right? ds equals to 2. Number of plastic hinges required to be formed is 2 plus 1, that is 3. What are the possible locations? It can form here, it can form here, it can form here, it can form here. 4 locations it can form. So you have to check all types of failure mechanism. That means, first of all, check formation of plastic hinge under the load. Check this criteria. Next, at the location where material changes, so check that criteria also. Fine. Next, at these 3 locations, check this criteria also. Fine. Or check this criteria also. These 4 criteria you have to check, and minimum of all the criterias is considered as collapse load. Minimum of all the criteria is considered as collapse load. Fine. You have to check all the criteria, and minimum of all those things will be considered as your collapse load. Okay. Any doubts up to here? You can ask me. Any doubts up to here? You can ask me. Any doubts up to here? You can ask me. Any doubts up to here, guys? If there is no doubt, we'll try to solve some of the questions. The question is, a steel beam with a constant EI and span L. Question number 3, this one. A steel beam with a constant EI and span L fixed at both ends carries a uniformly distributed load which is gradually increased till the B reaches the stage of plastic collapse. Assuming B to be at midspan, which of the following is true? A fixed beam subjected to UDL and point B is at the midspan, A and C are at the fixed supports. He is asking which of the following statement is true. So which of the following statement is true if it is being asked like that? Hinges are formed at A, B, C together, that is option A. Hinges are formed at B and then at A and C. Hinges are formed at A and C together, then at B. Hinges are formed at A and C only. What is the answer? What is the answer? What is the answer? Prithviraj, once you solve the problem, you will understand. First, try to solve this problem. Fixed beam subjected to UDL and A is at the A and C are at the ends, B is at the center. Fine. So he is asking hinges, how hinges are formed. Hinges are formed at A and B and C and simultaneously. Hinges are formed at B and then at A and C together. Hinges are formed at A and C together, then at B. Hinges are formed at A and C only. What is the option? Option C. So I have discussed that. First, hinges are formed at A and C. At 12 MP by L square, hinges are formed at A and C. And if you increase the load up to 16 MP by L square, hinges formed at B. So first hinges are formed at A and C, then at B. I have discussed that just now. That is one thing. Now, a fixed beam is subjected to a load W at 1/3 of midspan from the left support as shown in the figure. The collapse load of the beam is a fixed beam subjected to W there is a fixed beam subjected to W at 1/3 of the span. This is L by 3, this is W, this is L by 2, this is also L by 2. Fine, and this is 2 MP, this is also MP. A fixed beam subjected to point load at a distance of L by 3 from here, What is the collapse load he is asking? Try to find out the collapse load. Please try to find out the collapse load. I have already given you a hint over here. You just have to check all the criterias. That means collapse load for this external work done equals to internal work done. 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 So here also check different criteria, and collapse load, minimum of all the collapse loads is your collapse load. So give me the answer. One path, Prithviraj other path, and Patnaik third path. I am fourth path. Who are the other three paths? Please do comment other 3 paths also. Shihana, she came at the starting and she left. And what about these guys? Initially who came? Pradeep. Where you went, Pradeep? Hi, Pradeep. Kuldeep. Hi, Kuldeep. Suhail Rathir. Hi, Suhail. Where are you guys? Neetu, where are you? Venkata Kalyan, how are you? I'll give you 3 minutes of time to solve this because this is a GATE question. Make it fast. Last 1 minute, guys. Last 1 minute. Last 1 minute. 1 minute. Last 1 minute. Time up. Fine. So what is that you have to do? What is ds? Static indeterminacy, r minus s. Number of reactions equals to 4. Number of equilibrium equations is 2. So 4 minus 2, that equals to 2. 4 minus 2, that equals to 2. So ds equals to 2. Number of hinges required to be formed is ds plus 1, that equals to 2 plus 1. Number of hinges required to be formed is 3. Fine. So number of hinges required to be formed is 3. What are the possible locations? It can form at x, y, z. I'll say this as some p. X, y, z and p. Fine. So first criteria, I'll take hinges forming at x, z and p. Okay. Hinges forming at x, z and p. Hinges forming at x, z and p. Now see here, Here what is the moment? Moment, you will be taking 2 MP here. Let us say this is alpha, this is L by 3, this is 2L by 3. So this is L by 3 times alpha equals to 2L by 3 times beta. This is beta. Okay. Next, at P it is also 2 MP. That means here it is 2 MP. Here also it would be 2 MP. And here the member meeting will be having a strength of MP. So here it is MP. And here it is alpha. Here it is beta. Okay. So if I write external work done equals to internal work done, external work done equals to internal work done equals to internal work done, external work done equals to internal work done, then what you can write is W multiplied with L by 3 times alpha, W multiplied with L by 3 times alpha, internal work done is 2 MP times alpha plus 2 MP times alpha plus beta plus MP times beta, MP times beta. 2 MP times alpha, 2 MP times alpha plus beta plus MP times beta, right? So W and L by 3 times alpha would be equals to 2L by 3 times beta. So alpha equals to 2 beta, or beta equals to alpha by 2. That you can write. L by 3 times alpha would be equals to MP 2 alpha plus 2 alpha plus 2 beta plus beta. So that is equals to MP 4 alpha plus 3 beta, beta equals to alpha by 2. So 8 plus 3, that is 11. 8 plus 3, 11. MP alpha by 2, that equals to W L by 3 times alpha. 33, that equals to 16.5 MP upon L. Collapse load equals to 16.5 MP upon L. 16.5 MP upon L. This is collapse load. This is one criteria where plastic hinges are formed at XPZ. Next criteria, plastic hinges forming at XYZ. If I say plastic hinges forming at XYZ, then plastic hinges are forming at X, Y and Z. X, Y and Z. Plastic hinges are forming at X, Y and Z. Here it is 2 MP. Here it is. If two members are meeting of different moment capacities, first failure will occur in weaker member, right? So here you will be taking MP. Here also you will be taking MP. Here also you will be taking MP. If this is theta, this is theta, this is L by 2, this is also L by 2, this would be L by 2 times theta, and load is here, load is here, fine. And if this is theta, this is L by 3, this will be L by 3 times theta, L by 3 times theta, and this one is theta, this is also theta, fine. So external work done equals to internal work done. If I have to write, W multiplied with L by 3 times theta equals to 2 MP times theta plus MP times theta plus theta plus MP times theta. So this value is 5 MP theta, that equals to W L by 3 times theta. W equals to 15 MP upon L. This is collapse load from second criteria, that is plastic hinges at X, Y and Z. Next, third criteria would be plastic hinges at X, P, Y. Fine. Plastic hinges at X, P, Y. If I take plastic hinges at X, P and Y. If this is L by 3, this would be what? L by 6. That means if this is alpha, if I am taking this as beta, this would be 2 MP. Here also it is 2 MP, 2 MP, 2 MP, and here it is MP, because if two members of different capacities are meeting, failure will occur at the weaker member. This is MP, 2 MP, 2 MP, 2 MP. And what you can write, L by 3 times alpha equals to L by 6 times beta. L by 6 beta. So beta would be equals to 2 alpha. Right? Beta equals to 2 alpha. If I substitute that, what I will get is W multiplied with L by 3 alpha equals to 2 MP alpha plus 2 MP times alpha plus beta plus MP times beta. So this equals to MP multiplied with 2 alpha plus 2 alpha, 4 alpha plus 2 beta plus this is 3 beta. W multiplied with L by 3 times alpha, MP multiplied with 4 alpha plus 6 alpha. W would be equals to 30 MP upon L. So what is the minimum collapse load? First criteria, what you got in first criteria, that is collapse loads at X, I mean hinges at X, P and Z, it is 16.5 MP upon L. Right? Next, second criteria, it is X, Y, Z. So you got 15 MP upon L. And third criteria, you got at X, P, Y, that equals to 30 MP upon L. Fourth criteria also you can check, that means at P, Y, Z, but it is of no use. Why it is of no use? Because work done by external load will be 0. If I am taking plastic hinges at P, Y and Z, P, Y and Z, what is work done by external load? There is no movement here. Work done by external load, external work done equals to 0. External work done equals to 0. So you don't have to check this criteria. So minimum of these three things. What is the minimum? Minimum is the collapse load. That is collapse load equals to 15 MP upon L. Collapse load equals to 15 MP upon L. This is how you try to find out the collapse load. It might take time, but this is worth question. If you solve this question, then getting the better rank is very much high, because many people can't solve this question. Okay, so idea is very simple. You have to check all the criterias, and finally whichever is the minimum, you have to give that. Since I am explaining this to you, it took me this much amount of time. If you solve it faster, you will solve it in 3 minutes, 2 to 3 minutes, not a bigger issue. So collapse load is 15 MP upon L. Collapse load is 15 MP upon L. Option is C. Collapse load is 15 MP upon L. Any doubts in this? You can ask me. 15 MPa upon L. Any doubts? Please do comment, guys. Any doubts? Any doubts? Please do comment. There is a person, Prudviraj. No doubts, sir. Can we get the PDF of steel workbook? I don't think so, because it should be purchased from GATE Academy website. You just have to purchase it. I can only give you problems here. In the same way, try to find out, for formation of collapse mechanism in the following figure, the minimum value Pu is CMP upon L. Collapse load is CMP upon L. MP and 3MP denote the plastic moment capacities of the beam sections in the figure. The value of C is. What is the collapse load he is asking? What is the collapse load he is asking? So the question that is given to you is there is a beam with a collapse load of Pu. This is 3 MP, this is 3 MP, and this one is MP. Okay, 1 meter, 2 meter, 2 meters. This is 2 meters. This is 1 meter. This is also 1 meter. 1 meter, 1 meter, 2 meters. This is Pu. So what is the collapse load? Please try to find out the collapse load Pu. In the same way, please try to find out collapse load Pu. Time is 8:33. I'll give you time up to 8:36. Please make it fast. Only 3 people are watching now. What happened here? You got angry that I asked you to purchase from GATE Academy. Sorry here, if you don't want, then I won't I can't do anything here. You have to buy this from Gate Academy website only. What is the answer, guys? How much time you'll take? Fine, I'll give you another 2 minutes extra. Please try to solve it. The answer is 13.33. Okay, now so I'll call this as some A, B, C, D. So first I'll take at A, B, C, D locations. This is alpha, this one is beta. Fine, and here it is 3MP, here also it is 3MP, and here also, here it won't be 3MP. If two members, here it is MP, here it is MP, here it is MP. 2 plus 1, this is 3, this is 1. So 3 alpha equals to beta, beta equals to 3 alpha. Fine. This is alpha, this one is beta. So external work done, external work done, external work done equals to internal work done. Internal work done. What is external work done? W or PU multiplied with 3 alpha equals to 3 MP alpha plus MP times alpha plus beta plus MP times beta, right? So this is equals to MP times 3 alpha plus 2 beta, and MP times 4 alpha plus 2 times 3, that is 6 alpha, equals to PU times 3 alpha. PU would be equals to 10 MP upon 3. PU equals to 10 MP upon 3. This is one thing. And he has asked what? Anyway, we'll keep it like this. PU equals to 10 MP upon 3. This is one thing. Next. Next. Next, plastic hinges at A, B, C. If I take plastic hinges at A, B and C. Three MP, and here it is MP. Here it is MP, here also it is MP, and if this is theta, this is also theta, this is 2 meters, this is also 2 meters, this is 2 theta, this is also 2 theta, this is the load PU, and this distance would be 1 times theta, 1 theta. I can write this as some theta, and here also it would be theta, here also it would be theta. External work done equals to internal work done. External work done equals to internal work done. PU times theta equals to 3 MP times theta plus MP times theta plus theta plus MP times theta. So that is equals to 3 MP plus 3 plus 2 5 plus 1 6, 6 MP times theta. So PU would be equals to 6 MP. Collapse load equals to 6 MP. Next, what would be the other criteria? Other criteria is formation of collapse load at C, D and B. C, D and B. If this is PU, this is theta, this is also theta, this is MP times theta, this is also MP times theta, this is MP times theta, this is also MP times theta. So fine, PU multiplied with theta, external work done is PU multiplied with theta equals to MP, 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 4 times MP theta. PU times theta equals to MP into theta plus MP multiplied with theta plus theta plus MP multiplied with theta. So PU equals to 4 MP. PU equals to 4 MP. And at ACD is of no use because external work done would be equals to 0. So if you see the first criteria, in first criteria PU you got 10 MP upon 3. In second criteria PU you got 6 MP. In third criteria PU you got 4 MP. What is the minimum of these three things? That is the first criteria is the minimum criteria, minimum, then collapse load, collapse load, collapse load PU equals to 10 MP upon 3. Fine. And he said what? CMP upon L. What is the L? L is 4 meters. CMP upon L. L is 4. So C value would be equals to 40 by 3. That is 13.33. Whatever that guy Prithviraj has got is correct. Fine. Any doubts? You can ask me. Prithviraj got it correct. What about the other guys? I don't know. So please do like, share, subscribe with as many people as possible. This is how you try to find out the collapse loads in fixed beams. In 2015, in morning session one question came, in evening session another question came. So if you have if you have attended the direct classes, then directly by seeing it itself you can tick it off. Anyway, this is how you solve it. Any doubts? Any doubts, guys? Screen is blurred. Why screen is blurred? For me screen is looking good. Now please check it. 8 people are watching, I think. Yeah, only 8 people are watching. What is this 8? 1, 2, 3, 4, 5, 6, 7, 8. Why can't be 80 people? Anyway, this is how you solve this type of questions. And one person said it is clear. Fine, well and good. Fine. This is enough. If there is any other questions that you are having, please solve it. Now Patnaik has asked some doubt. Sir, what is kinetic and static method of solving the questions? See, whenever we are talking about the structure is, first of all, you can use equilibrium equations, because structure is in equilibrium equations. Structure is in equilibrium, so you can use equilibrium equations to find out the collapse load. Sigma Fy equals to 0, summation of moment equals to 0. So to find out collapse load, first we can use equilibrium equations. Second one, mechanism condition is, what exactly is mechanism condition is, number of hinges formed should be sufficient to convert a structure into mechanism. Should be sufficient to convert a structure into mechanism. That means number of hinges required to be formed is ds plus 1. So you have to convert a structure into mechanism if sufficient number of hinges are formed. That is another condition to find out collapse load. And third condition is yield condition. So according to this, bending moment at any point, according to this condition, just a minute. According to this condition, bending moment at any section should be less than plastic moment capacity. Fine. Bending moment at any section, then only failure will not occur, right? This is another criteria. Fine. By using these three criteria, if you solve, you will get a collapse load. That is a unique collapse load. Fine. If all the above three conditions are satisfied, then collapse load obtained is known as true collapse load. If all the three conditions are satisfied, then collapse load obtained is known as true collapse load. If any of the two conditions are satisfied, then you'll get different methods. So first one is kinematic method. Kinetic method. If first condition and second condition is satisfied, or I can say if equilibrium condition and mechanism condition is satisfied, then the method is called as kinetic method. And collapse load obtained is more than true collapse load. Collapse load obtained, P is more than or equal to true collapse load. Next, static method. If equilibrium condition and yield condition is satisfied, then method is known as static method. Collapse load obtained from this method is less than true collapse load. That means P is less than or equal to PU, where PU is the true collapse load. This is whatever the load that is obtained by using these two equations. That means if you are using these two conditions to solve the problem or to find out the collapse load, then it is called static method. If you are using these two things, then it is called as kinetic method. This is also called as upper bound method. Kinetic method is also called as upper bound theorem or upper bound method, because load obtained by using this method is more than true collapse load, and load obtained by this method is less than true collapse load. So static method is also called as lower bound method. Fine. So but we are not using this, we are using principle of virtual work done to find out the unknowns or to find out the collapse load. Fine. Any doubts in this? You can ask me. Board is not visible. What happened here? For me, board is being visible over here in YouTube. What happened to you? Why board is not visible? Please check your internet connection. For me it looks clear. I don't know about you. Please check your internet connection. Patnaik, I think your doubt is clear over here. I mean, your doubt is satisfied over here. Next, with this I'll close today's session. To everyday morning 7 to 9 I wanted to take. Today I have taken only half an hour to 1 hour, I think. So in the morning 7 to 9, evening 7 to 9 I would like to take. So please do attend the classes, and if people are not attending, I am not discussing much. Tomorrow is Sunday, I think it should not be a problem. So please do attend from morning 7 to 9 and evening 7 to 9. Okay. So today we have discussed majorly how to find out the collapse loads. That is an important concept, that's why I have discussed. So please be clear with it. Fine. Thank you. Good night. Bye bye.